Hello guys, welcome to our class for today. This is Noble Mind Science Tutors Online and I am Otubo Michael. For our class for today, we are going to be looking at light waves. So we're going to introduce light waves, and under light wave we'll look at sources of light, shadows, we'll look at luminous objects and non-luminous objects. Then we'll also look at transmission of light. We'll talk about, under transmission of light, we'll look at opaque, transparent, and translucent objects. Then we'll also treat rays and beams, different types of beams, convergent and divergent beams. Then we'll look at rectilinear propagation of light and what it can lead to, formation of shadows and eclipse. Then we'll also treat the pinhole camera and magnification of the pinhole camera. Then we'll now solve some problems on the magnification of pinhole camera. So guys, if you are ready for us, we are also ready for you. But before then, try and get your writing materials so that you can easily flow along. Okay, so if you have not subscribed to this channel, please, what are you waiting for? Please subscribe to our channel, click on the notification bell so that whenever we upload a new video, YouTube will notify you. Okay, so also give us a thumbs up, give us a like, help us to share these videos, and also invite your friends. Right, you can help us to share it on YouTube, Facebook, Instagram, and all that. Right, you can also reach us through the WhatsApp number that is showing right on your screen. So if you are ready, we are also ready. So let's go to the class for today. Transmission of light, light waves and its transmission. Okay, so let's go. As I said, we are introducing light wave. So light is a form of energy that is known as luminous energy. And what light helps you to do is that it helps you to see. So it brings about the sensation of sight or the sensation of vision. And that is why you can see. Alright, so it is the rays of light that we see that gives us that sensation of vision. So light wave is a form of electromagnetic wave, and it can travel through a vacuum and other material medium. Okay, so the velocity of light in different medium is what is stated here. So in a vacuum or in air, this is the velocity of light. Then in glass is the velocity of light 2.0 times 10 to the power 8. Then in liquids is your water, it is 2.3 times 10 to the power 8. As we progress this, it will get to a point where we are going to use these values to solve some problems. Okay, so what are some of the sources of light? Okay, so different sources can produce light, but mostly the sources of light are classified into two, depending on how the light is emitted. So one of them is luminous objects. When you say luminous, it means that that object can bring out light. Okay, like in the night, firefly, or like your sun, the stars, they can produce their own light. So objects that generate and emit light by themselves are known as luminous objects. So example is the sun, the stars, fireflies, and other form of some form of artificial light like candle lights. Okay, so this can be classified as luminous objects. Now, what are those objects that cannot generate their own light? They rely on other luminous objects to give light. Those objects are known as non-luminous objects. An example of them is moon. So moon is not luminous, while sun, the stars, they are luminous objects. Okay, so these are majorly the sources of light. So we have two sources of light, luminous objects and non-luminous objects. Okay, So these are the sources that give us light. Now, how is light transmitted, or what influences or what affects transmission of light? That is what we are going to treat in our next, as we progresses in our next slide. Transmission of light. Okay, as we have discussed before, light ray can actually travel through a vacuum, through solid, liquid, and gases. So the fact that light travels through a vacuum shows that light does not require a material medium for its transmission. Okay, so whether there is a material medium, whether there is no air or whatever, light can travel through that medium. Okay, so light does not require a material medium for its transmission, but remember that sound require a material medium for its transmission. Okay, so there are objects that can actually allow light to pass through them or allow light to be transmitted through them, while others does not allow light to be transmitted through them. And that is what I want to discuss now. Opaque objects. When you say an object is opaque, it means that the object will totally block off or cut off the transmission of light. So these are substances that do not allow light rays to pass through them. Example is like your stone, wall, wood. These substances, they don't allow light to pass through them, so they are known as opaque objects. Then transparent objects. These are substances that allow large amount of light to fall upon them and then pass through, like glass. Yes, glass and water allow light to pass through them. So any object that allow light to pass through them, they are known as transparent objects. What about translucent substances? These substances allow very small amount of light to pass through. So what they do is that because they allow very small amount of light to pass through them, you cannot see object through them very clearly. Example is a piece of paper, right? You know that a piece of white paper will allow light to pass through, but the object that is underneath, you will not see it very clearly. So object like that, or like a tissue paper, objects like that do not allow large amount of light to pass through them, but very small amounts, they are known as translucent substances or translucent objects. So it is good you take note of this. Opaque objects, they don't allow light at all. Transparent allow a large amount of light to pass through. Then translucent, they allow very small amount of light to pass through them. Okay, so this is this is what happens when light passes through different substances. So we are going to go straight to rays and beams. So what is a ray of light? A ray of light is a direction or path traveled by light energy, and it is represented by a straight line with arrowhead to indicate the direction of travel or propagation of the light. So if you see this, these are rays of light. This is one ray, this another ray, this another ray. Now a collection of rays is what is called a beam. So when you have more than one ray traveling, it is called a beam. So there are three types of beams. We have parallel beams like this. These are parallel beams. See these rays that are collected together. They are moving in the same direction and they are parallel to one another. So we have parallel beams. Okay. Other types of beams that we also have convergent beam. So for convergent beams, all the rays, they will come together and meet at a point. That's why it is called convergent. Then for divergent beams, all the rays, they will leave one point and spread out. So when the rays spread out from a point, they are called divergent beam. Then when they converge at a point, they are called convergent beams. Okay, so having known this, we'll now be talking about rectilinear propagation of light. Rectilinear propagation of light. When you say rectilinear, it means straight line, right? Straight line, that is rectilinear. Okay, so we are looking at rectilinear propagation of light. What is rectilinear propagation of light? Rectilinear propagation of light is the traveling of light rays in a straight line. This can be verified by the formation of shadows on screen and the formation of image in a pinhole camera. So for you to show that light travels in a straight line, you can use either shadows to show it, or you can use the pinhole camera to show it. And under shadow, we'll talk about eclipse, formation of eclipse. Okay, formation of eclipse is also a proof that light travels in a straight line. So shadows are formed when an object is placed in the path of light rays coming from a point source, just like this. Okay, so this is the point source of light, this is the object, and then this is the shadow that is cast on a screen. This tells you that light travels in a straight line. And when you look at this shadow, this is a whole shadow, and because the shadow is whole, it is called umbra. Okay, so umbra is total darkness. Area of total darkness is called, or is known as umbra. And for you to have an umbra, the source of light must be a point source of light. So the umbra is the area of total darkness. A point source normally produces sharp image called umbra, and that is exactly what I have said now. Then penumbra. Penumbra is an area of partial darkness due to the partial light received and large source of light. So sometimes, if the source of light is large, you'll find out that there's an outside this thick shadow, there's another shadow that is not as thick as this one. That shadow that is not as thick as this one is what is known as penumbra. Okay, that's what is known as penumbra. So this is what I'm just talking about now. This area of partial darkness is called penumbra. Why? Why do you have this area? You have this area because of the large source of light. So the point source of light will give you this sharp shadow, while this light source of light will give you this penumbra. So please take note of this drawing. Sometimes in your examination, they can ask you to draw this simple diagram showing an umbra and a penumbra. So you should be able to know how to draw this simple ray diagram. Okay, one beauty about light wave is your ability to draw ray diagram. So if you don't know how to draw ray diagram, please, I will encourage you to start to practice how to draw ray diagrams, because there are times that you might not even be able to explain a point very clearly, but you can use just your diagram to explain it. So if somebody now asks me that explain what is umbra and what is penumbra, and I cannot explain it clearly, I can use I can use this ray diagram to explain it. I will just draw it and say this is the umbra and this is the penumbra. Your examiner will give you your full mark. Yes, so please learn how to draw ray diagram. I think it is in physics, it is in light waves that you really need to draw diagrams. Light waves and maybe electricity, but especially in light wave, you must know how to use rays of light or lines of rays of light to be able to locate the image of an object. Okay, so it is very key that you begin to practice how to draw this simple diagram. So as I said, rectilinear propagation of light also leads to the formation of a eclipse. It leads to the phenomenon that is called eclipse. So what is eclipse? Eclipse occur when one heavenly body, either like the sun or the moon, casts a shadow on another heavenly body. That is when you have an eclipse. So there are three types of eclipse. We have solar eclipse or eclipse of the sun. We have lunar eclipse or eclipse of the moon. and then annular eclipse. So this is supposed to be lunar eclipse. That is lunar eclipse. So we have lunar eclipse, eclipse of the sun, and then annular eclipse. So as I said before, you must learn how to draw this diagram, and then also know how to just the small labeling. So this is eclipse of the sun. The solar eclipse or eclipse of the sun occurs when the moon is between the sun and the earth, and then the shadow of the moon is cast on one section of the earth. The shadow of the moon is cast on one section of the earth. So people within this region, they will be in total darkness. While people within this region and this region, they will have penumbra. So they will just be seeing the shadow of the moon very faintly, but they will not be in total darkness. Okay? So people here will not be in total darkness. People in this region, they will be in total, because this one is giving you umbra. So eclipse of the sun occurs when the moon comes between the sun and the earth. When the moon casts its shadow on the earth, you have eclipse of the sun. The lunar eclipse occurs when the earth is between the sun and the moon. So when the sun casts its shadow on the moon, you have eclipse of the moon. Then when the earth casts its shadow, when the moon casts shadow on the earth, you have eclipse of the sun. Then when the earth is between the sun and the moon, you have eclipse of the moon. So here the earth will cast its shadow on the moon. Okay, so then we now have annular eclipse. For annular eclipse, the moon is also between the earth and the sun, but the only difference is that the ray that is coming from the sun, they will intersect earlier. Okay, the extreme rays that are coming, they will intersect earlier, so a shadow like a ring is what will be formed. A shadow like a ring will be formed. So this was that this occurs when the moon is in its course of rotation and revolution is further away from the earth, such that the tip of the umbra form fails to reach the earth due to the intersection of the extreme rays before reaching the earth. This results in the appearance of a bright ring around a central dark portion. So as I said, this eclipse occurs when the rays that are coming from the sun, they intersect before reaching the earth, and because of that, you now have a ring like a round, a central dark portion. That's what they will see. Okay, so that is what is known as annular eclipse. Okay, so we've talked about what retinal propagation of light can cause. They will also use the pinhole camera too to show that light travels in a straight line. So the pinhole camera is what we want to discuss now. So this is just a diagrammatic representation of a pinhole camera. So this is supposed to be like a box. Then you have a pinhole on it. That pinhole you can actually construct a pinhole camera. It's easy to construct. You can get a small box of you can get a carton, okay, like maybe a carton of biscuits. Then you try to seal up all the open ends. Seal up all the open ends so that there will be no light entering the box. Then cut off one part of it and put a white screen, like a white paper, like a printing paper, A4 paper or A3 paper, gum it on one side. Then the opposite side of it, use your pin to put a hole, just pierce it. Just pierce it so that it will be a pinhole. Pierce it there. Okay. Then you can get, if you want to now use it to practice in order for you to form an image, you can put a candle light in front of it. Yeah, put a candle light in front of the camera. Make sure that you have a somewhat a dark place. Yeah, you can do it in a dark room so that you see the image here. Because if it is in a place where you have where a place that is well lit, you will not see the image on this screen clearly. But if it's in a dark room, you will see this image. So let it be in a dark room. Position the camera, I mean the box, on a straight line with the candle. Then look, check the back, check the screen. You will see an inverted image that is smaller than the image of the than the object itself. You will observe an inverted image on the screen that you have created. Okay, so that shows that the formation of this image shows that light travels in a straight line. Okay, so the PO camera is also used to verify that light travels in a straight line. It consists of a light bus, a light-proof bus, with one end having a small pinhole, while the opposite end has a screen made of white paper. Light from an object placed in front of the pinhole passes through it and form an image on the screen. The image is inverted. That is exactly what I have discussed with you now, right? So the sharpness of this image will depend on the size of this hole. If the size is too large, your image will be blurred. That's why I say use a pin to pierce the hole. Forget about it. Light will find a way through the hole. Forget about, just pierce it with a pin. Alright? So that is it. Then the size of the image depends on the distance of the object from the screen. Okay, so these are some of the factors that affect the image form in a pinhole. One of them is the size of the pinhole. Another one is the distance of the object from the distance of object from the screen. These are the factors that affect the type of image formed by the pinhole camera. Now, these images that are formed by the pinhole camera, they also have some characteristics. One is the one you are seeing here. The image is inverted. The image is inverted. The image is real because it can be formed on a screen. Then the image, look at the size of this and this one. The image is smaller than the object. So these are some of the characteristics of the image formed by a pinhole camera. Besides those characteristics, there's another thing that we need to calculate or find from the PO camera, that is the magnification. Magnification of the image formed by a PO camera is given by image height all over object height equals to image distance all over object distance. So it depends on the variables that you are given. You can use any of this one, or you say image size all over object size. Or you can also say magnification is equal to length of camera all over object distance from the pinhole. So depending on the variables you are giving, you can use any of these formulas to solve to get the magnification of a pinhole camera. That's okay. So having said that, we'll just solve some problems so that we can be able to, so that we can drive home some of the points that we have discussed. Okay. So this is a sample question. It says that the height of an object placed at a distance of 60 centimeters from the pinhole camera is 15 centimeters. So let's look at that part first. It said that the object height, I will represent it with capital H. Object height represent with small h. Okay, sorry about that. So I will represent object height with small h, while image height with capital H. So this is my object height. The object height is given to me to be 15 centimeters. Then the image distance, or the object distance u, I give it as u to, it's given to me to be 60 centimeters. Let's say if the length of the camera is 10 centimeters, so let me say length of camera L is equals to 10 centimeters, 10 cm. Calculate the magnification produced by the camera. So say calculate M, it's not given there, magnification, then you see, and then the height of the image, H, capital H, that's what they say we should look for. Okay, so from the equations for magnification, we had that magnification is equals to length of camera all over object distance from the screen. Okay, so that is what we have. We have that magnification is equals to length of camera all over object distance. So if we know that object distance is equals to 60 centimeters, length of camera is 10 centimeters. So we can just do that. Magnification is equals to 10 all over 60. So if you work that out, you have this will cancel this out. Then you do your division. So if you do your calculation, you have 0.16 as the magnification. Okay, so that is magnification. Then say calculate the height of the image. Okay, so we know that magnification is equals to magnification is equals to image height all over object height. So which means that image height will be equals to what? Magnification times object height. So do that, 0.16 0.166 multiplied by the image height, which is 15. If you multiply that out, you have approximately 2.5 as your image height. So if you look at this image height and the object height, what are you seeing? The image is reduced, and that is actually the type of image that you get from a pinhole camera. The image is always smaller than the objects. Okay, the image is always smaller than the objects. So if you compare the two heights, you see the difference in their height. So this is how to use those formula that we just discussed to solve for some problems. Okay, so let's try our hand on another one. So this is another question. Say that a boy 1.5 meters tall stands 2.0 meters in front of a pinhole camera of length 20.0 centimeters. Calculate the height of his image. Calculate the height of his image. So here you are given that the height of the boy is 1.5 meters. That's image height. The distance that the boy stands, which is object distance, is 2.0 meters. The length of the camera, of the PO camera, given to you to be 20.0 centimeters. So convert this one to meters so that you have 0.2 meters. Because you look at all these other variables, they are in meters. Okay, so you're now asked to calculate the image height. This is what you are finding. So we see that from our formula, we have that image height, all of our object height is equals to image distance, or since we don't give us image distance, is equals to length of camera all over image distance. So just substitute to this. So you have h, image object height all over 1.5, which is the image, all our object height is image height all over object height is equal to length of camera, which is 0.2, all divided by the image distance, which is 2.0. So make the object height, the image height, the subject of formula. You have 0.2 multiplied by 1.5, all divided by 2.0. By the time you solve that out, you are going to have that image height is equals to 0.15 meters. If you multiply it by 100, you have 15 centimeters. So this is your image height. So if you compare your image height to the object height, you will see that the image height is smaller. Okay, you see that the image height is smaller than the object height, and that is what the pinhole camera does. Okay, the image is always smaller than the object. So this is how to apply these formulas. All right, now this is your test page, so please try and solve all these problems. Try and solve all these problems. They are not too difficult. Okay, check your textbook. You see other questions like this. So this is a JAM question, this is a wire question. They are just like the ones we have done already. So you don't have any problem with this. Okay, so guys, thank you so much. This way we are stopping this class for today. And there are other topics that we have to discuss on light waves. But for now, this way we are stopping. Thank you so much for your time. And then before I go, please, if you have not subscribed to our channel, please subscribe to this channel. Click on the notification bell so that whenever we upload a new video, YouTube will notify you. This is Normal Science Tutors Online, and this is your physics online tutorial. As I've always said, you can reach us via the WhatsApp number that is showing right on your screen. If you have any challenge, please bring it up. We'll discuss it together and see how we can help you. We want to make you a better student in physics. Is that okay? So please solve a lot of problems from your textbooks. They will help you to understand the concept in physics. Okay, so reach out to us, give us a like, give us a thumbs up, invite your friends, help us to share this information. Okay, thank you so much for staying with us. We appreciate you. See you in our next class.